start actually with pixi-pack. So let's imagine that we create a super cool project using Pixi, and now we have all our dependencies specified in our Pixi toml, and Pixi has logged everything in our pixi.log file. But now we want to actually deploy this project. The obvious question now is, how can we actually do that? The classical way for this is to containerize it. So for this, we also actually have a nice Docker image, which can be found from on ghcr.io/prefixdev/pixi. Yeah, but what happens if Docker is not available where we want to deploy it? So for example, imagine that your target environment is a Windows server where you want to deploy things onto, or maybe it's just a Linux machine that you can't fully control and can't install Podman or Docker onto. And for this, with the help of some colleagues, I have created a tool called pixi-pack that helps in exactly these scenarios. It reads your pixi.log file and generates a tarball containing all relevant conda files that are required for building the package. So the file internally looks somewhat like this. We start off with a pixi-pack JSON and a environment YAML file with some basic metadata. And the actual interesting part is what's happening in the channel directory here in this tar file. This is basically just a local conda channel with all the conda packages that we need to install our package. In order to install the environment on our target machine, we would just need to install all of these conda package in our environment, and that's it. No internet required whatsoever. Since we are only shipping .conda files and .tarbz2 files, it's actually trivial to create cross-platform pixi packs, basically. For instance, I can just download the Windows conda packages on my MacBook using pixi-pack, and then send the packed file, the environment tar, to my Windows server, and then just run pixi-pack unpack on that Windows server, and everything works. conda-pack is another project that has similar goals as pixi-pack, but it has the drawback that it always requires an installed environment that you can then pack. So if you want to pack cross-platform, this can definitely lead to some issues, as it's not really trivial to install Linux environments on Windows and vice versa. Another use case for pixi-pack that just fell into place naturally is archiving. So imagine you found a really cool project online and want to ensure that it still works on your machine even after the inevitable downfall of the internet that we know, but you still want this project to run. Or maybe the package just gets removed from conda-forge for some reason. And with pixi-pack, you can just create the environment tar once and then always rebuild it, since it doesn't access the internet at all and has all files necessary locally available. Enough about the theory. Let's actually try it out. All right, so I'm in a directory. I have basically a small pixi toml prepared. So here we can see we have Python as a dependency and PyTorch, for example. And what we now do, we can see we have our pixi log file also as well. And what we can just do is run pixi-pack pack. And then it basically downloads all of the conda packages, and then it created an environment tar file here. And if I now want to install this, I can run pixi-pack unpack environment tar, and then I also specify the shell that I want to create shell hooks for, because I'm on fish and not on bash. And then what we can see now here is that it's installing, and here we can see we have this activate.fish file and an env directory. And the env directory is actually like our regular conda environment, and the activate.fish file basically just is our file that we would need to source in order for the environment to activate. So this is basically pixi shell or micro:bit activate or that stuff. And now we can basically run Python and do things like import torch, for example, and then you see that this works even without invoking any pixi command or any conda command. It just works out of the box without needing pixi or conda at all. So this is basically really cool. How you can deploy it manually. And the other thing that we can maybe do is show you how to actually deploy it cross-platform. So we can run, for example, pixi run pack, and then we can specify pick platform, and then pack it to a different location, for example, to environment linux 64.tar. So it does that now. Now I downloaded that. Now I have this environment file as well. And what I now need to do as well is to basically once download the pixi-pack binary, so get it from GitHub, the GitHub releases. We now have it basically here. Obviously, since I'm on a MacBook, I can't execute it here, but what I basically now need to do is ship this file and ship this pixi-pack Linux to my Linux target machine, and then I can unpack everything. Yeah, Torch startup does quite a lot, takes quite a lot of time. Yeah, and so this is now my target machine. It's an Ubuntu x64, so we can see here that's an Ubuntu x68-64. And what we can now basically run is pixi-pack Linux, and then unpack environment linux64.tar. Then it's doing some unpacking and extracting all of the files. And yes, then we basically have exactly the same scenario. We have our environment and we have our activate, and we can activate everything. You can see that our Python is exactly the right Python that we want, and yeah, now we can also import Torch again, but yeah, as Julian already mentioned, the startup times, actually they are here quite fast. Yeah, so this is basically pixi-pack in a nutshell, how it works. Any questions so far?
Yeah, that's awesome, Pavel. Thank you for showing the real life demo. That always helps. I had a question that are you already using this in some production environments, and how is it received?
This was actually the original motivation for it. We tried out conda-pack at first, and there were some reproducibility issues and some flakiness and some errors involved, and then we just decided to rewrite it in Rust, and now it's I think it's not deployed yet, but it's definitely on the being used and already tested.
Amazing, it's great.
Do you think this would? I think it will, but do you think it will also be a solution for environments that don't have access to internet? Like you could even bring it on the USB stick, right?
Yeah, you can bring it on a USB stick or get it somewhere in some way to there, and then work with that.
Nice.
I was wondering how your experience with Rust was, and if you liked the interfaces of Rattler, or how that went.
Yeah, I would say the interfaces of Rattler, we basically, I mean, the code is not that large. It's maybe like 400 lines of code. Most of the heavy lifting is luckily done by Rattler, so we didn't really need to implement a lot of stuff. So I can recommend just using the Rattler library. It was very fun to work with.